Welcome to the class, Tatu.
Oh, hello, sir.
Are you well?
Fine, thanks for yourself, sir.
Did you get any results yet of
Yes,
last
sir.
term's exam?
Yes, sir.
Okay. Did it go well with the science?
It didn't go well with anything, sir, to be honest.
Really? With anything?
No, sir.
Okay. And the science? I'm really actually only concerned about the science. What does it mean that it didn't go well? You didn't get what? You didn't get what you wanted? Or did you do really
Yes.
bad?
I think both at I didn't get what I wanted.
Okay.
And
But did you do very bad? Did you get below 60%?
Yes, sir.
Really?
Yes, sir.
Below 50?
I got like in my 30s, sir.
Really? But that isn't on. There's no way you can actually get hold of the question paper and your physical memo.
I have them on my computer, but I don't have a phone anymore.
You don't have a phone anymore?
Yes, sir.
Well, why don't you mail it to me?
Okay, do you have okay, can I write down your
Your
email address?
I think Dean's got my email address. Just speak to her. Maybe you can. I want to look at what you've. I want to look at how you've answered the questions.
Okay, sir.
Otherwise, what we must do, we must make a lesson and then we run through that paper with you.
Must I ask Auntie D for like your thing?
Yeah, what we can do maybe next week, Tatu, is just find a way to get it to me, the question paper, and then we're going to go through the question paper. I want to see how you've actually answered the question and what you've made. Because that mark is too low.
Yes, sir.
I would expect you to get at least in the 50s.
Yes,
the lowest mark that I'm thinking that you should get is like 55. You shouldn't get lower than 55. I mean, it's not that you don't understand the work. 30% means that you don't have a clue what's happening, basically. And that isn't true. So I want to actually look at how they've marked your stuff. Do you understand? I want to actually look at what you've written and how they've marked it. So maybe next week, what we can do, I'll just, on this whiteboard, I'll just put the questions and your answers next to one another. And we want to work through them.
Yes, sir.
Okay.
Yes, sir. I can ask Auntie D to send them to you right now.
Yeah, she can send them to me in the next day or two.
Yes, sir.
Maybe, I don't know how you're going to do it. Scan, mail, I'm not sure.
By email.
Yeah.
Sure.
Then I can have a look at it and then we go through it next week.
Yes, sir.
Okay.
Can I go tell her? She's just right here right now.
Yeah, just make a note of that.
Yeah.
Huh? Yes. Are we busy with electrostatics?
Yes, sir.
Okay, what have you done here?
So far, I've done forces between charges, the magnitude of charges, distance between charges.
Okay. Done Coulomb's law?
Yes, sir.
Okay, you've depleted that, Coulomb's law. But you haven't done electrical field strengths? No.
I started with it today because I was doing the net force and I started electrical fields, the direction and electric field line.
We'll do that soon. But I want to start off with Coulomb's law. But before we do that, let's just look at something that you need to be able to do from grade 10.
Yes, sir.
Okay, let's just start here. Okay. Now, this chapter is very important to somehow just in your head, just divide the chapter into two sections. One is Coulomb's law. Coulomb's law, we discuss the force between two charged particles or spheres or whatever. So I might have sphere A or particle A and B. And I want to know what the force is between those two spheres. And
Yes,
therefore, you'll find that the equation has got two Q values in it. It means
yes, sir.
both of these
I charge.
spheres do have charges.
Yes, sir.
Well, electrical field strength is just, if you imagine the following, let's imagine there is a magnet here. And I'm putting like a metal pin at spot X, a certain distance from that magnet. Then in this part of the chapter, I want to know what is the electrical field. So what is the field strength at that certain distance? So there's only one. Now they can change this magnet into a normal sphere. It doesn't have to be a magnet, it can be a sphere. And normally
Yes,
they
sir.
just use a sphere that's charged. So let's say this is a positive charge. Therefore, in this equation, I only have one Q value because there's only one component that has got some charge on it. X
Yes,
is
sir.
just a spot, it doesn't have any charge. So we're going to look at Coulomb's law first. Okay, so Coulomb's law, as I said, let's assume that I have sphere A here and B here. So now I want to determine what is the force, either the force that B exerts on A or A on B, they will be exactly the same because of Newton.
Yes, sir.
Or I want to know what is the forces, what is the force between. There's two keywords, on or between.
Mm-hmm.
Okay. I'll do that grade 11, grade 10 revision right at the end.
Yes, sir.
Okay, let's give values here. Let's assume that A has a charge of 3 microcoulomb, or
Yes,
let's say
sir.
positive 3, and B has negative 2 microcoulomb. Okay, so let's, before we start, just explain to me, what does micro mean? What does nano mean? And what does pico mean?
Mm.
Micro is times 10 to the power of minus 6. Nano,
Oh,
yeah, is times 10 to the
yes.
power of minus 9. And pico
And
is times
to
10
the
to the power of
power.
minus 12. You also get
Yes, sir.
micro.
Which is 10 to the power of -3.
Yeah, but we don't really use that because this value is not small enough. We can still write it in decimal form.
Oh,
So
yes, sir.
pointless, yeah. You can get it, but I never see. They rather just give you a charge of 0,002 Coulomb, which is micro. But it's not that small, so I can still write it in decimal form. Okay, so I want to know if the distance is, let's say, 30 centimeters between those two spheres. I want to know what is the force. What is the force between A and B? I can either ask what is the force between A and B, or I can ask you what is the force that A exerts on B. These are slightly different questions. The answer is the same, but the direction that you answer the question in is different. So let's do the black one first. The first question. What is the force
Yes, sir.
between A and B? Now, the between answer is going to be attractive at the end. The force between them is an attractive force. Well, if I ask what is the force that A exerts on B, A exerts a force in direction west. Can you see that? Or left?
Yes, sir.
So there's just a different way of answering those two. The answer is going to be the same. But if I ask you what is the force between them, it's either attractive or repulsive force. While if I'm asking you what is the force that A exerts on B or B on A, there will be a force in Newton answer and then a direction in either east, west, north, or south. So let's do this.
Okay.
Let's use
Yes,
it.
sir.
And then also last thing, you need to know what K is. K is a constant value of 9
it's a
times 10
constant.
to the power of 9. Okay, let's do that. So the force is K, Q or of A times Q of B over R squared. Now, very important. Let's just use the right units. So that's 9 times 10 to the power of 9. And then I have 3 times 10 to the power of minus 6. That's the charge on A. Just take note, I'm not putting in the positive or negative values. Times 2 times 10 to the power
Why
of
is that, sir?
Pardon? Say
Why
that
are you not putting like the negative or positive?
because the negative and positive just gives me the direction at the end of the answer. So I already know that the answer is going to be attractive because of the negative and positive values. I don't put those values in because I don't want a negative I don't want a negative force answer. I want a positive force answer with a certain direction. If you put a negative 2 in there, you're going to be tempted to give a negative force answer, and that they're going to be penalized for that. And then I have to convert 30 centimeters into meters. So that's 30 divided by 100 squared. Okay.
Oh, you must always divide it into meters.
Always go to meters. Yeah, the standard unit is meter. Right, I want you to type that into your calculator, see if you can do it.
Okay, sir.
I get an easy, interesting answer, easy one. Or I get 0.6 Newton.
I get 3/5. Yes, sir.
That's 0.6
Yes, sir.
newtons. And I want to know
Newton.
the force between. So that's attractive force. Do you write attractive?
Sir?
You also use the word attractive.
Yes, sir.
Yeah. If the question was A exert on B, it would have been west. You understand that?
Oh, yes, sir.
Okay, good. Okay, write that down or screenshot that. Just going to revert to some, use other values. We're just going to play around. I want to play around with the formula first.
Yes, sir.
See if you can work the formula. You can tell me when I can wipe this.
Yeah, you can go on, sir.
Okay, good. Just going to set up a new sum, change some of the values.
Okay.
Right. Okay, let's say that A as a +2 nanocoulomb charge and B has a +5 nanocoulomb charge. The force between them is 0, no, it's a dumb answer. Let's make it 5,23 times 10 to the power of minus 4 Newton. That's the force between them. I want to know what is the distance between A and B.
Must I solve it?
Yeah, if you can, be excellent.
Okay. Let me do it. Okay. F equals 2 Q1 Q2 R squared.
And then you're going to show me how to do it.
Yes, sir. 2 9 okay. Squared. and this is equal to um, 10, 9. Oh, whoa, wait. Time.
Struggling.
No, so no, not at all. Equal. Time 10, 17, and from there I gotta divide.
I get 0,013 meters.
I'm not done yet, so I'm left with one more thing.
Okay.
Um, 0,013.
Do you get that?
Yes, sir.
Very good. Okay, we can quickly just go. So the force is 5,23 times 10 to the power of minus 4. The K value is 9 times 10 to the power of 9. And then I have 2 times 10 to the power of minus 9. That's the one charge. And the other one is 5 times 10 to the power of minus 9. And that's divided by r squared. So now what I do, I just put it in my calculator and solve x or solve r. But what you've done, did you multiply all three things on top?
So no, I divided the 9 comma with the thing and I multiplied the thing. Then I took the r to the left side.
Okay.
Then the sum, I took it to the right hand side and I square rooted and I got my answer.
Your answer is correct. 0,013 meters. Very good. Okay. Tests completed. So now you can do this basically. Okay, this we can do. This example we've done. Right, let's go. Okay, now this is a classic type of exam example we're going to do now. So the first question is, number 1, there's two spheres, P and R. Can you actually see that? Is it big enough?
I have good eyesight, so I can see it.
Okay, they are 40 millimeters from one another. And the one is 2 nanocoulomb, the other one is positive 3 nanocoulomb. I want to know, what is the force that R exerts, so R exerts on P. So in other words, what is the force of R on P? So you're going to write it like this. The force of R on P is K Q of R times Q of P divided by R squared.
So
Okay, and that's 9 times 10 to the power of 9. And we have 2 times 10 to the power of minus 9 times 3 times 10 to the power of minus 9 over 40 that needs to go to meters. So I'm going to divide it by 1,000 squared.
yes.
The force of R on P. Okay, and I'm going to take note that they are both positive. So what R is doing to P, R is pushing P to the left.
It's pushing. Yes, sir.
And we call that west. And I'm going to draw a little north thing like that. North, east, south, west. Right, and then we type that into the calculator.
Okay. I
Yes.
get 3,375 times 10 to the power of -5.
Newton. Very good. West.
Yes,
Bang.
Newton.
I'm not going to bother. Well, you'll probably have to write it as 3,38. Is that correct? 3,38.
Yeah, if they ask to, yes, sir.
Yeah, it's normal to actually ask you to round off to 2 decimals, but I'm just going to leave it like that for now. All right. Now the second
Yes, sir.
question, if they ask you 2 decimals, you must give them 2 decimals, eh? Then you're going to do
Yes, sir.
3,8 there. Okay, now the next question is we're going to add another charge, S. And it's got a charge of -7 nanocoulomb. Now, I want to know, what is the distance from R? We should place S so that the net force on P equals 0. So I want to know, what distance should we place that from R so that the net force of those two charges on P gives me a value of 0? So let's just set up an equation for what we're basically asking. I'm asking, when is F net on P 0? Now the net force on P, is what? Is the force of R on P plus the force of S on P. Is that correct?
Sir?
Have a look at what I've
The-
just written.
Please repeat.
So we have P
Yes,
here.
sir.
There's P. So what R is doing, R is pushing P in that direction.
Yes, sir.
And what S is doing, S is pulling P
It's
in
pulling
that
R.
direction because it's got a negative charge.
Isn't it pulling
Yeah.
R, sir?
That negative charge, that -7 nanocoulomb is actually pulling P towards it. You see that?
Oh. So, sir, can I please ask, right?
The force of R on P is
You wrote
west. We've just worked that out. Well, the force of S on P is east. Can you see that?
sir, I think you wrote the thing, the middle is supposed to be R, not P.
Yeah, I know, but I'm not talking about the middle. I'm talking about the net force on P.
Oh, okay, sir.
So that is P. And R is pushing P towards the left, while S is pulling P towards the right. Do you agree?
Yes, sir.
Okay. Do you want to take down a small note before we continue?
I'm already doing that, sir.
Okay.
Where's P East? Yes, sir. Done.
All right. Okay. So I'm just setting up an equation for us, like a scaffold to work with, a framework. Okay. So I've got that value. I've got the force of R and P. We've just calculated that, and that was
Yes,
west.
sir.
So I'm going to choose west as positive. Okay.
Okay.
So the net force is 3,375 times 10 to the power of -5 plus the force of S over P. Is that correct?
Yes, sir.
So basically, the force that S must have on P will be -3,375 times 10 to the power of -5. You agree? I'm just throwing that over.
So
So I'm going to take that negative out. And I'm going to write the west. Sorry, east. Because it's got a negative value, which means it's east. So I'm going to take the negative
sir.
out and make it. So now I have the force. So now I
Yes,
can
sir.
use this equation. Force is KQQ on R squared. So 3,375 times 10 to the power of minus 5 equals my K value. And then those two forces. It's 2 times 10 to the power of minus 9 times 7 times 10 to the power of minus 9 over R squared. Now, very important. We're going to calculate R again, like we did just now. But
Yes, sir.
R is going to give me the value from the middle of P right to the middle of S. And I'm just going to take that value and subtract 40 mole from that to get the distance from R.
Yes, sir.
Okay, go.
Okay. 7 times 10. All right.
I'm cheating. I've got that calculator. I just put that formula in and press solve.
Yes, sir. Okay.
You're faster than me.
No, sir, I'm not. Uh, um. Okay. Then I'm just like this. Sir,
Yes.
if I am correct, my answer is 6,110 times 10 to the power of negative 17.
Ooh, I don't get that. I just get 0,06.
Oh, can I backtrace?
Okay, let's work it out together. So what you've done, you've divided the 9 underneath that value. Is that true?
Yes,
Okay,
yes,
let's
sir.
go there. So it's 3.375 times 10 to the power of negative 5. And that you divided with 9 times 10 to the power of 9.
Yes, sir.
So that gives me 3,75
Times 10 to
to
the
the
power
power
of
of
negative
minus
6.
15.
Yes, sir.
That gives me, I'm going to also multiply those two top values with one another.
Yes, which gives me 1,4 times 10 to the power of negative 17.
I think so, yeah. But I'm just going to put it in my calculator. Yeah. 1,4 times 10 to the power of minus 17.
Yes, sir.
So now I'm going to take this blue value and divide it with the yellow value, and then take the root of that answer. Is that correct?
Yes, sir. Oh, 1,4.
And then take root answer equals, and then I get 0,06. So you take the 1,4 and put it on this fraction thing in your calculator.
Sir. Yes, sir. Yes, sir. Sorry, sir. I miscalculated.
Okay, good. So the answer is 0,06 meters.
Yes, sir.
Awesome. Okay, this is a classic like exam type sum. The reason is they make it easy to start off with. Everyone gets 3 marks. Then they
Yes, sir.
add something for another 5 marks. And that 5 marks is difficult to get because you have to write all these equations. You can't just go without writing these equations.
Oh,
I see 6 marks. Someone added a mark. I don't know. Oh, no. It is 6 marks, but we don't have 6. We only have 5. Why? We have not subtracted the 40 millimeters. Therefore, the distance equals the 0,06 meters minus 40 millimeters. So that's 40 divided by 1,000. And then I get 0,02 meters. And that's the distance between R and S, not P and S, because the question is R and S.
yes, sir.
Okay, one more example, a different one. Bang. Okay, let's just pull this one closer.
Okay.
Let's see what happens here. So I've got a sphere, let's say S, and there's P. Now P's got a positive value, and S also got a positive value. So these two spheres, they push one another away. They don't attract one another. They what's the right?
They are
They're repulsive forces.
yes, sir. Repulsive, yes, sir.
Okay, and then S and R are a positive and a negative, so they attract one another. So they might ask you just to work out what is the force that P exerts on S. So what's the force of P on S? Okay, that's quite easy. Let's make it red. The force of P on S is K. Remember, you must always write these formulas. If you don't write the formula, you can't get the marks. So that's 9 times 10 to the power of 9. And we have a positive 3 nanocoulomb times a 2,5 nanocoulomb value. And that's over 0,003 squared. All right, let's do that.
Q2. Must I do it or
Yeah, just type it in your calculator. So we just can't confirm the answer.
so
Okay, I made a little mistake there. See if you get the same value I do. 7,5 times 10 to the power of minus 3 Newton.
I get 7,5 times 10 to the power of -3. Yes.
Newton.
Yes.
And I'm going to say south.
Yes, sir.
Good. I think that's 3 marks. Second question is, what is the net force on S? So let's just backtrack and see what's happening here. If we put S there in the middle somewhere, then P is pushing S down. This is the force of P on S. But R will attract S in that direction. Is that correct?
Yes, sir.
So the net force will be here somewhere where these two meet. There you'll find the net force. Agreed?
Yes, sir.
So this is, we can use Pythagoras to do that.
Oh.
Remember, with vectors.
Yes, sir.
Good. So the first thing we need to do is calculate the force of R on S. Okay, let's do that. 9 times 10 to the power of 9. And I still have those values in my calculator, so there's only one value I need to change, basically. This is a 4 nanocoulomb value. 4 times 10 to the power of minus 9. And the distance there is 0,005 squared. So I go back to the calculator and I only change the values that I need to change. I don't have to retype in the whole thing. I need to change the previous 3 to a 9, to a 4, and the 0,3 to a 0,5.
I get 3,6 times 10 to the power negative 3.
Yes, good. Let me just get this pen. So it's 3,6 times 10 to the power of negative 3 Newton, and that would be east.
Yes, sir.
Okay, but that's not the question. The question is, what is the net force? So the net force is the sum of both forces, or Pythagoras rather, it's easier.
Yes, sir.
That is the root of FR over S squared plus the force of P on S squared. Okay, let's do that.
Okay.
Okay, so that is 7,5 times 10 to the power of minus 3 squared plus 3,6 times 10 to the power of minus 3 squared.
So I get an answer of 8,319 times 10 to the power of negative 3.
Okay, good. Right, so the net force is 8,32 times 10 to the power of minus 3. And now I've also have to give direction. So this is gonna,
So,
I have to get that angle there. See that?
yes, sir.
So in vectors, we did that. Okay, so I've got the here 3,6 times 10 to the power of minus 3. And I got here 7,5 times 10 to the power of negative 3. So I can use tan alpha, and that is opposite, which is 7,5 times divided by adjacent, which is 3,6. I'm leaving out the 10 times 10 to the power of minus 6 because that's
So they
only,
cancel out each other.
yeah. So shift tan 7.5
Which
over 3.6.
64,36 degrees.
Yes. And then I can use that, and my answer, I can use 64,36 degrees south of east, or I personally like to use geographical reference. So I'm just going to add 90 degrees to that. Then I get 154,36 degrees. Okay, look at that.
Yes, sir. I'm done writing down the notes I was writing with you.
Are you done?
Uh-huh.
Okay. Good. Now, let's see if there's another example. There is no example. Let's just do that quick grade 10 revision.
Okay.
Okay, I've got two spheres, A and B. And they might be either standing on stands or they might be suspended by like pieces of wire or whatever, or non-conductive rope or whatever from the ceiling. So A touches B. What happens if they, say for instance, we've got now two ropes on them. They're going to be drawn towards one another, isn't it?
Yes, sir.
Why?
Because one is negative, one is positive.
Yes, opposite charges attract one another.
Attracted.
What
Yes,
happens
sir.
is these two spheres, they come closer to one another and that they touch one another. And once they
Will share
touch
the
one
energy.
another, then the electrons are equally dispersed over
Shared.
both of them.
Yes, sir.
So now they can ask you one, what is the charge? What is the charge on both after they've touched? Can you
Is
remember
this
that?
where, yeah, where the Q nu equal? Oh, I vividly remember it. Yes, sir.
Okay, Q net is Q of A plus Q of B divided by 2. Is that correct?
Yes, sir.
Good. So now we have 2,5. You can either use micro Coulomb if you want to, or you can change it directly to Coulomb plus a negative 3 times 10 to the power of minus 6 over 2. Right,
Yes,
let's do
sir.
that. Okay, do you get like negative 2,5 times 10 to the power of minus 7 Coulomb?
Okay, can I just write this?
Yeah, just jot that down. We have lots of time.
Negative 2,5 times 10 to the power of 7. Yes, sir.
Good. Okay, that's the charge on both afterwards. Then they can ask you how many electrons were transferred.
Oh, yeah, then,
Electrons go from B to A.
yes, sir.
Good.
B, oh, yes, sir.
From the
Because
more negative,
electrons move.
yeah, from the more negative one to the more positive one.
Yes, sir.
Okay. How do we do that?
So we know that one electron equals to 1,9 times 10 to the power of negative 19. If I'm,
It's 1,6.
oh, yes, sir. Yes, sir. I think we multiplied by the 3.
Okay, this is the equation. N equals Q over QE. So the amount of electrons, which is N, is the change in charge divided by 1,6 times 10 to the power of minus 19. Plus or minus, eh?
Yes, sir.
That can be a plus or a negative. The sum will determine that. So the amount of electrons, we need to find out what is delta Q.
Isn't
So what is
delta
the
Q?
change in charge? The change in charge is the final charge minus the initial charge.
Yes, sir.
Okay, you can use any one, A or B, it doesn't matter. We'll give you the same answer. One answer is negative, other answer is positive. So let's use A. The final charge on A is negative 2,5 times 10 to the power of minus 7, minus the initial charge of 2,5 times 10 to the power of minus 6. We're just going to put that in the calculator. So I get negative 2,75. Negative 2,75 times 10 to the power of minus 6 Coulomb. That
Yes,
is
sir.
change in charge. Okay, good. So therefore the amount of electrons is negative 2,75 times 10 to the power of minus 6 divided by, now I use the negative value, negative 1,6 times 10 to the power of minus 19. And then I get 1,72 times 10 to the power of 13 electrons. Got that?
Yes, sir.
Good. We're going to set up a new sum. Interesting one.
Okay.
You find it first. Where can I find it? Let me quickly find something else that I actually want to do. No, it's nowhere. Oh, it's under the next chapter. So we're not going to do that now. Let's do this one.
Is this still under grade 10 revision?
No, it's not. It's under Coulomb's law again.
Okay, sir.
Okay, fifth example. Look at this. We have three spheres.
Yes, sir.
Okay, the top one's got a positive 3 nanocoulomb charge, and then B and C has got negative 3 nanocoulomb charges. Then they are both 10 millimeters from A, and the angle between BAC is 120 degrees. I want to know, what is the net force on A? 8 marks. What is F net on A? No, it would probably be less than 8 marks. 6 marks maybe. It's not that difficult.
Okay, 3.
Once I show you what to do, then you say, oh, okay, it's not that difficult. So the thing that makes this sum kind of easy is that both of these charges are exactly the same.
Yes,
So
sir.
let's just draw some diagrams here. What does B do with A? B is drawing A towards it. It's attracting it towards it.
Yes, sir.
Okay. So what B's got an X and a Y component. So let's make this one red. It's got a component there, which is X, and a component there, which is Y.
Yes,
The
sir.
Y component is downwards, and the X component is to the left. Do you agree?
Yes, sir.
So what does C do? C is attracting A towards him. Also
Yes, sir.
also has an X component, and it also has a Y component.
Y component. Yes, sir.
X component is in that direction, and the Y component is also downwards.
Yes, sir.
So these two X components, they cancel one another because they are exactly the same, because these
Yes, sir.
charges are the same.
Also the Y.
Also the Y. So I can say the force B on a X component equals the force of C on A's X component. That's correct. So I don't even have to worry about them. They're the same. Also, if these two triangles are the same, then I have a 60-degree angle there and a 60-degree angle there.
Therefore, by angle B and angle C are 30.
They are 30. So I can literally draw a little triangle like this and say it's 30 degrees there. I have a Y component there, and I have an X component there. And this here is the force of B on A. Agreed.
Yes, sir.
So let's calculate the force of B on A. This is K Q on R squared. So that is 9 times 10 to the power of 9. Then I have 3 times 10 to the power of minus 9. That's the A value, charge, and B's charge is the same. And the distance is 10 divided by 1,000 squared. So let's put that in the calculator. Eight comma 1 times 10 to the power of minus 4.
8,1 times 10 to the power of negative 4. Yes.
Newton. Okay. I'm not going to give a direction now because it's not a question.
Yes, sir.
I don't have to give the direction if it's not a final question. So I've got that. Now I can get the y value. What is y? Sine of 30 is opposite over adjacent. Is that correct?
Yes, sir.
So the y component is the force of B over A sin 30. And that is 8,1 times 10 to the power of minus 4 times sin 30. And I know that answer. That's going to be 4,05 or something. 4,05 times 10 to the power of minus 4 Newton. And this is south. Okay. Well, what is the net force? The net force, look, those x components are cancelling. They are like cancelling one another. So the net force on A is basically just the y component of B. So the force of B on A y component plus the force of C on A's y component. And they're exactly the same, those two y components. Can you see those triangles?
Yes, sir.
So basically that is 4,05 times 10 to the power of minus 4 times 2. Or plus another one. This is probably not a cool way to write it. Just say plus another 4,05 times 10 to the power of minus 4. And that's exactly back where we were. 8,1 times 10 to the power of minus 4
4.
Newton south. So this is all you need to know, except all the theory, of course, like a
Yes, sir.
definition and stuff like that. This is all you need to know with regards to the Coulomb sums.
Really?
Yeah, they can ask you, I'll show you what else they can ask you in a short question. It boils down to the same type of stuff. Do you want to quickly just copy this? Or
Yes, sir. Let me just do this.
screenshot that or whatever?
Yes, I'm done.
Good. Okay, so they can say, for a short question, they can have a sphere A and a sphere B, and they can say the force equals F.
The force equals F.
Yeah,
So that means it's unknown.
yeah, it's unknown.
Okay.
It's just F. So the force between them equals F. The distance equals r. So I'm going to half the distance between them. Halving this is, what will the new force be?
It will be 2F.
Okay. Exactly. Okay, I think you're wrong. Okay, they're gonna option A is gonna be the force is gonna be F. Option B is gonna be 2F. Option C is gonna be 4F, and option D is gonna be half F. So we know already that A and D is wrong.
Yes, sir.
Because if you change the distance, then you'll change the force. So you can say the force is directly proportional to the product of the two charges divided by the distance squared. So the charges stays the same.
Yes, sir.
Force is indirectly proportional. I can just leave it like that. So Q and Q will stay the same, but the distance will be a half R now. Is that true?
Yes, sir.
And I'm squaring that. So that becomes QQ over a quarter R squared. If I take the quarter up, it becomes 4QQ over R squared. And QQ over R squared is F. So that's 4 times F. So C is the correct answer.
Oh,
Remember, the distance between them squared. And if you square 2, it becomes 4. If you,
yes.
that's the same with that Newton universal law of gravitation. It's the same type of sums. Okay. We're gonna have class next week again.
Yes, sir. We have in class next
You
week
don't have
again.
maths. You don't take maths classes. No.
Oh, I don't.
No, you don't.
Okay, sir. Yes, sir.
I'm just making sure. I'll see you next week again. Remember, try to get those stuff over to me.
Yes, sir.
Keep well.
Yeah, thank you, sir. Bye.
Yeah.